linear equations. And specifically, we're going to talk about the slope-intercept form of a linear equation. Slope-intercept form is y equals mx plus b. M is the slope, b is the y-intercept. So let's go ahead and see what this next slide says. It says graph the linear equation. So if you notice, this is a little different than mx plus b. Okay, mainly it's because the x isn't first. So what I'm going to do is I'm just going to flip those two around. Okay, reason I did that is because I can now see that the slope is what? The slope is -2. That is the coefficient of the x. Okay, so here's my slope. My y-intercept is what? 3. So I'm going to go ahead and graph my equation using those two things. So a y-intercept of 3 means I'm going to put a dot at 3 on the y-axis. What's the slope of -2 mean? Down 2 over 1, because if you remember, slope is rise over run. So if I have a whole number, I just put it over 1. So slope of -2 means down 2 over 1. Down 2 over 1. Remember, we always like 3 points as opposed to 2. And then now all I need to do is draw the line. Now, is this the only way that I could have graphed that? What would be another technique that we've used to graph in the past? Computers. Okay, yes, we've used the computers. What else? The very first way you learned how to graph. Do you remember making a T-chart? Okay, the very first way. Now, the thing about a T-chart is, it is a little bit more labor intensive, but that is still an option. Remember, you could let x be 3 values, and then you would just plug it in and find y. I think this way, using slope and y-intercept, is a lot faster. Okay, so let's go ahead and look at this next one. This says find the equation of line AB. So my equation, if you remember, involves the slope and the y-intercept. So I'm going to find each of these two things. So my slope is going to be the rise over the run. So if you notice, this is already nicely labeled. The rise here is what? 3. What's the run? 4. So basically, I just pick 2 points on the graph. I find the rise over the run, and that is my slope. What is my y-intercept in this problem? -2. Now that's just where it intersects the y-axis. So my equation, y equals mx plus b. Now you could also just have 3/4 x minus 2. You don't need the plus negative, but it's whatever you prefer. That's it. So you think you can handle that one? Oh, we got 2 more we're going to look at, and then we'll be done for today. It says find the equation of the line that passes through the points 4, 6, and -2, 3. So there are 2 ways to do this. One, I could actually plot the points and graph them, and then solve it the way I did previously. Or I could use the formula for slope. Does anybody remember the formula for slope? Yep. Well, y2 minus y1. So in this case, 3 minus 6 over,
-2 minus 4.
in this case, -2 minus 4. Okay. So what is 3 minus 6? -3 over -6. So my slope here is 1/2. Now, do you know the y-intercept? Do we know what b is? We don't know what b is, so we've got to find what b is. Okay, so I'm going to take a point. In this case, I'm just going to use the first point. Could I use the second point? Yeah, doesn't matter. So I'm going to plug in 6 for y and 4 for x. Why did I do that?
So you can solve for
So I can solve for b. Okay, what's 1/2 times 4? 2. Okay, what does b equal now? 4. Now if you remember, it asked me for an equation. It didn't ask me for the y-intercept. So what I need to do now is use this green equation that I have here, and in place of b, I'm going to put 4. Okay, so first step, find the slope. Once you find the slope, put it in the equation, plug a point in, find the y-intercept. We're going to look at another one, just because I want to see how well we do. Okay. Look at this one. It says find the equation of the perpendicular bisector of the segment with endpoints 2, 9, and -4, -3. Perpendicular bisector, what can you tell me about it? Intersects the middle of the line. So what I need to do is find the middle of this segment. Okay, I'm going to find that point in the middle. So what would be the point in the middle between 2 and -4? -1, right? Now if you're kind of wondering what you could do, you could actually put a number line, and you could just say like 2, -4, 1, -3, 0, -2, and then you get to -1. What about the y-coordinate? What's halfway in between 9 and -3? 3. So this is the point it goes through, right? Now I need to find the slope of the line. So I need to find, if it's perpendicular, what do I know about its slope?
It's the opposite.
Opposite reciprocal. Okay, so now let's find the slope of this line first. Okay, the slope of that line. I'm going to take what minus what on the top? -3 minus 9. Divided by, what am I going to do on the bottom? -4 minus 2. So what is -3 minus 9? -12. What is -4 minus 2? -6. What is -12 divided by -6? +2. Okay, so basically to find the slope, remember I just take y minus y, okay, divided by x minus x. Now could I switch those and take 9 minus -3 divided by 2 minus -4? Yeah, I could do that as well. So now we're going to do the same steps we did in the problem before. Y equals, oh, almost. If it's the perpendicular bisector, what's the slope actually going to be? -1/2. Okay. So now I need to plug in the point, -1, 3. So I'm going to plug in 3 for y, and I'm going to plug in -1 for x. So what is -1/2 times -1? 1/2. So now I need to take 3 minus 1/2. And what do you get? 2.5. I'll let 2.5 go today. Okay. So I come up here to the green equation, and my equation will be y equals -1/2 x plus 2.5. All right, so you kind of have to see what the problem asks you for. So let's go ahead and turn in our book and look at our assignment. It's on pages 289 through 290. Okay, pages 289 through 290. Okay, so the first one says graph the linear equation, the first 3. We looked at that. The next one says write an equation. We looked at that. The next three say write an equation for each pair of points. We looked at that. And then last but not least, we looked at some of the last ones. So you have looked at pretty much every type of problem here. Okay, 9 and 10 are a little different, but you should be able to handle those.